Alright, today we're talking about 4.2, which is amplitude and period. So just as a heads up, if you have any questions on the homework, I highly recommend you ask as soon as you can, because this is about to get pretty intense. And if you have some problems or some issues with what we've covered so far, we want to get those straightened up as soon as possible. So like we said, we're going to talk about period and amplitude today, but this is to remind you what the parent sine function and the parent cosine function look like. Remember, they're this wave action. Another reminder, the standard period, as we know, is 2 pi. That just means that after 2 pi, so from 0 to 2 pi, or from really any distance from any distance of 2 pi in the graph, after 2 pi it's going to start repeating. And as another reminder, the amplitude, the standard amplitude is 1, and that just means the factor by which I'm stretching it up and down. So if it's 1, it's just going to be in between -1 and 1. But if it's more, we're going to be stretching it up and we're going to be stretching it down. So this is what we're going to talk about today. So just to start off, we're going to introduce this new formula, the standard sine function formula. A times the sine of b times c, x minus c plus d. And before we get so intimidated by this, we're going to take it one step at a time. So we're just going to deal with multiplying by a value of a. Sine x is going to stay the same here. So we say my amplitude here is 3 because I'm multiplying out front of the sine. My a value is 3 here. So we say my amplitude is 3. Well, all that really means is we're going to stretch it up and down, the parent sine function, up and down by a factor of 3. So let's graph the original sine function again. Remember, standard period is 2 pi. So I take 2 pi and I'm going to graph 4 key points. So we take 2 pi divided by 4. And my key points are pi over 2 away from each other. We start at 0. And my 4 key points are going to be at, let's draw my increments here. Pi over 2, that's the first one. Pi over 2 more is pi. 3 pi over 2. And then 2 pi. Now let's discuss what, just a review to get us started, sine x is the y value, so on my unit circle, the y value at 0 is 0. The y value at pi over 2 is 1. I'm going to make my 1 right there. And we're going to be a -1 at some point too. That's 1. Then pi is a y value of 0. 3 pi over 2 is straight down, so y value -1, and then back to 0. So this dotted graph here is my original parent sine function. But what happens when we multiply by 3? The only thing that happens is every y value gets multiplied by a factor of 3. So 0, that stays at 0. 3 times 0 is 0. A y value of 1 multiplied by 3 comes up to 3. So he gets stretched all the way up to 3. Another 0 times 3 is 0. -1 times 3 is a -3. So this one gets pushed down to -3. And then 2 pi, which is 0, 3 times 0 is 0. So the answer to this problem, the one I'm going to be looking for on the test, is this red graph here. This amplified graph. All it means is that it gets stretched up and it gets stretched down. So let's do another one. 2 cosine x. We're going to graph it on 0 to 2 pi, so 1 full period. Well, as a quick review, we're going to do this one pretty quick. Remember, cosine now is the x value of my unit circle. So we're going to deal with the x values. Remember, I'm going to have 4 key points, so my key points are going to be pi over 2 away from each other. So we start at 0. We have pi over 2. Another pi over 2 is pi. One more pi over 2 is 3 pi over 2. And then the last one is 2 pi. You'll notice these are repeating. That's okay. That's what it's supposed to be doing. Alright, so we're going to be, my original cosine function is going to be in between -1 and 1. We should recognize that hopefully by now. The x value at 0, well, that's just 1. So we're up at 1. At pi over 2 is straight up, so we have a x value of 0. At pi, x value of -1. 3 pi over 2, an x value of 0. And then pi over 2, we're back up at an x value of 1. So again, this dotted line is what we're looking for the original cosine, the parent cosine function. But what happens when I multiply this by 2? I get amplified by 2. I multiply every y value by 2. So this y value of 1 becomes a 2. This y value of 0 multiplied by 2 stays 0. Negative 1 multiplied by 2 gets pushed down to negative 2. 0 times 2 is 0. And then this gets also pushed up to 2. So this purple line here is what I'll be looking for on the test. All it does is it gets pushed up and pushed down. So let's introduce, we're going to introduce now the idea of what if we don't have these whole numbers? What happens if we get a crooked number like 1/2? Well, the exact same idea is going to happen. All we're going to do is multiply by the y values by this 1/2. So you could probably guess by now that instead of getting stretched up and stretched down, we're going to be squished closer to the x-axis. So let's graph this. Let's graph the original sine function. Remember, 1 full period, 0 to 2 pi. So my key points are going to be 2 pi over 4 or pi over 2 away from each other. So hopefully you can just graph those figure out what those are on your own. Pi over 2, pi, 3 pi over 2, and then 2 pi. Let's graph the original sine function. It's going to be in between 1 and negative 1. So hopefully now you can graph your key points. I'll again graph this with the original one with a dotted line. So now when we multiply by 1/2, we multiply every y value by 1/2. Well, 0 times 1/2 is 0. 1 times 1/2, though, becomes 1/2. So you'll notice that it gets squished closer to the x-axis. 0 times 1/2 is 0. Negative 1 times 1/2 is negative 1/2. And then 0 again is 0. So that red curve now is 1/2 sine x. So now we're going to introduce a period change. Now a period change just means how many periods am I going to fit into my original 2 pi period. In order to see that, remember if we go back to this y equals a sine or cosine, I'll stick with sine for consistency, b times x minus c plus d. I'm dealing with the b value now. So what we say when we mean by we're changing the b value is what we're multiplying by this x. So my b value here is 2. Now we're given this nifty little formula that tells me the new period based on what my b value is. So we plug in b is 2. So we have p is equal to, the new period is equal to 2 pi divided by the absolute value of b. But the absolute value of 2 is 2, so my new period here is pi. So in other words, I have to fit my 1 full cycle of this sine graph in pi instead of 2 pi like we had before. We have to make it go twice as fast. But it's important to note my bounds here, 0 to 2 pi. So if one period now, one of the new periods, is pi, I have to draw out 2 full periods of this in 2 pi. Hopefully this will make more sense in a little bit. Another way to think about it, if my b value is 2, that means I have to fit 2 full periods in my original 2 pi period. We'll see some more examples of that. So I need to figure out how far away my key points are. Well, I'm going to do the same thing. Now, we took my full period before, which was 2 pi, so we're going to make my new full period pi divided by 4 key points. So I have to make my key points pi over 4 away from each other. We still start at 0, but my 4 key points now are going to be pi over 4, pi over 2, which is another pi over 4 away, 3 pi over 4, and then 1 pi. Now my amplitude isn't changing, so I'm still in between 1 and negative 1. So it's going to look the same. It's going to go through these increments like we had before. However, they're just labeled differently. So don't get intimidated by the change in intervals here. So this is 1 full cycle of sine in a pi pi period instead of a 2 pi period. But remember, I have to draw two full periods like we said before because we're drawing from 0 to 2 pi. The only thing that's going to change here is my intervals, is what I label my increments as. We're just going to copy paste the graph. However, I need to label my intervals right. So I'm going to have 4 more key points because we're drawing a whole new cycle. What's pi over 4 plus pi? Well, that's just 5 pi over 4. And then we get 6 pi over 4, or 3 pi over 2, 7 pi over 4, and then 2 pi. Again, it's going to look exactly the same. The only change that we made was what I labeled my intervals as. So I'm still going to be up at 1 on the first interval, back to 0, down to -1, and then up at 0 again. And we're just going to connect the graph. So this is 2 full cycles of sine within an original period, in the period of the original parent sine graph. So remember, to figure out the new period, we just plug it into this formula, 2 pi over b. That's going to change slightly when we get to tangent, but we'll get there when we get there. So find the amplitude and period, and then sketch 1 full cycle of this cosine 1/3 x. Okay. So we need to find the amplitude and period. We're not multiplying by anything out front, so my amplitude is still just 1. What's my new period, though? My new period is going to be, well, 2 pi divided by my b value, which is 1/3. So I multiply by 3. My new period is 6 pi. So I have to stretch this thing out horizontally to 6 pi. I'm going to only graph 1 full cycle, so I only need to graph the cosine graph once. So I need to figure out what my new key points are. Remember, we take our new period, 6 pi, divided by, and I want 4 key points. So my key points are going to be 3 pi over 2 away from each other. So again, I'm just going to have 4 key points. I know I'm going to be in between 1 and -1 because I'm not changing my amplitude here. And I know that I'm starting at the x value of 0. My first key point is going to be 3 pi over 2. 3 pi over 2 plus another 3 pi over 2. Well, that's just going to be 3 pi. And then another 3 pi plus 2 is going to be 9 pi over 2. And then 6 pi. Now it's important to know that this cosine graph is going to look exactly the same as every other cosine graph we've drawn before. The only change that we made was what we're labeling my key points as. So I'm still going to start up at 1, go down to 0, go down to -1, up to 0 again, and then back up to 1. And then we just connect using my wave graph. That is 1 full cycle of this cosine 1/3 x. Again, to emphasize, we're not changing what it looks like right now. All we're changing is what my labels, my increments are. So let's do one where we have everything together. We have an amplitude change, we have a period change, and we're going to draw this from 0 to 4 pi. So let's not get too anxious now. I'm going to pretend like this -3 over 2 isn't here right now. We're going to graph sine 1/2 x to go step by step. So what's my new period? Well, my new period is going to be 2 pi, the original period, divided by my b value of 1/2. Sorry, absolute value. I want to get in the habit of that. Multiply by 2. So I have a 4 pi period. So it's important to make the link now that I'm graphing from 0 to 4 pi. My new period is 4 pi, so I'm only graphing 1 cycle of this. Okay, so we're going to graph it without the amplitude change yet. So my key points, remember I'm going to have 4 of them, so 4 pi divided by my 4 key points, so my key points are pi away from each other. 1, 2, 3, 4. So my first one is at pi, 2 pi, 3 pi, 4 pi. Okay, without the amplitude change, I'm going to be in between 1 and -1. Now let's just draw this. It's a sine graph, so we're starting at 0, going up to 1, back to 0, down to -1, up to 0. So this is my sine of 1/2 x. Now what happens when I multiply by this -3/2? All we're doing is we're multiplying every y value by -3/2. So this 0, well, that's just going to stay 0. What's 1 times -3/2? That becomes -3/2, or -1.5. 0 times -3/2, 0. -1 times -3/2 becomes a positive 3/2. So that gets pushed up to the top, and then back to 0. Notice what happened. Whenever I was positive before, when I multiplied by -3/2, it gets pushed down to the bottom. It flips it over the x-axis. So whenever we have a negative sign out front, the only thing that happens is it flips it over the x-axis. It reflects it over the x-axis. So now we're going to introduce what we call a vertical shift. So remember, going back to my original a sine b times x minus c plus d, we're introducing this value for d now. So we'll talk about that at the very end, what happens when we do that. Let's graph 2 sine 1/4 x. Hopefully by now you can recognize that I'm going to have an amplitude change, so my values are going to be between -2 and 2, and I'm going to have a period change. Let's find out what the period is. My original 2 pi divided by 1/4, multiply by 4, top and bottom. I have a period now of 8 pi. So to find out what my key points are going to be, 8 pi divided by 4, my key points are going to be 2 pi away from each other. So let's draw 2 sine 1/4 x. My key points are going to be at 2 pi, 4 pi, 6 pi, and then at 8 pi. And without this -1, I'm going to be in between 2 and -2. Remember, because of my amplitude change. And now it's just a sine graph. Up to 2, 0, -2, 0 again. So that's my 2 sine 1/4 x. Now what happens when I tack on this -1 at the end? The only thing that happens is it literally just picks this graph up and it shifts it down 1. It moves the entire graph down 1. So every y value gets moved down 1. So this 0 value here gets moved down to -1. This 2 value gets moved down to 1. 0 gets moved down to -1. This -2 gets moved down to -3. And the 0 value gets moved down to -1. And then we just connect the dots again. So if we want to think about this -1 line becomes my quote-unquote new x-axis. So all we do is we take the graph and move it down 1. So let's talk about this negative tangent 1/3 x plus 1. Well, we got to remember what tangent looks like. Remember, the original tangent graph had asymptotes at -pi/2 and pi/2. Then remember, it just looked like this disco curve. So let's start by drawing out what my new period is going to be. Remember, my original period for tangent is pi. It straddles the x-axis, and half the period's on the positive and half the period's on the negative. So to find the new period, we're going to take, instead of 2 pi now, my original period was pi. So I have to take pi divided by my b value, 1/3. So that becomes 3 pi. Remember, this entire period has to straddle the x-axis. So I have to have half of my period on the left-hand side, half of it on the right-hand side. So if I take 3 pi divided by 2, it's going to be -3 pi/2 on the left, and then 3 pi/2 on the right. Remember, those are where my asymptotes are. So everything I'm going to draw now is in between those two dashed vertical lines. So what happens when I multiply this thing, my original tangent graph, by a negative sign? Remember, it just flips it over the x-axis. So instead of going from bottom left to top right, it's going to go top left to bottom right. Sorry, and I should have made that a dashed. I got rid of a bit of my x-axis there. So that's my negative tangent 1/3 x. Now what happens when I move this thing with a vertical shift of +1? Remember, all that happens is it moves every point up 1. So if we remember back to when we defined tangent, there's a point at 1 here, which was originally pi/4. However, that's going to be changed now. I don't remember off the top of my head. However, there's these points at -1 and +1. Those are just going to be moved up to 2 and then to 0. So 0, this one gets moved up to 2, and then my origin gets moved up to 1. And then we just connect the dots again. And that's one full cycle of this negative tangent 1/3 x plus 1. The key thing to remember was half of my period gets straddled on the left-hand side. The other one is on the right-hand side. So I had to take my full period, divide it by 2, and then split it between positive x and minus x. Then the minus sign just flipped my original tangent graph over the x-axis, and then my +1 just moved everything up 1. So for this last problem, we're going to leave the hardest for last. We're going to draw out 1/2 cosecant 2x plus 1. So to start, instead of drawing cosecant, I'm going to start with its reciprocal identity. So I'm going to draw 1/2 sine 2x plus 1. And then I'll draw out the cosecant. So let's start by drawing out y equals 1/2 sine 2x. Hopefully that should be fairly easy now. It's an amplitude change. Its amplitude is 1/2, and the period now is 2 pi, because that's the original period of sine, divided by 2. So I have a period of pi. I'm going to draw out 4 key points, so my key points are going to be pi/4 away from each other. Pi/4, pi/2, then we get 3 pi/4, and then pi. So remember, instead of going up to 1, this thing has an amplitude of 1/2. So we go from between 1/2 and -1/2. And then it just looks like a sine curve. Start at 0, go up to 1/2, down, -1/2, 0. So just to illustrate this vertical shift now, every point we move up 1. So the 0 point gets moved up to 1. It's just going to get kind of high here. This 1/2 gets moved up to 3 halves, 1.5. 0 gets moved up to 1. -1/2 gets moved up to 1/2. Missed a point there. And then 0 gets moved up to 1 again. So this is my 1/2 sine 2x plus 1. Now remember my bounds here. All I've drawn right now is this graph between 0 and pi. But I was told to draw it between 0 and 2 pi. So I'm just going to copy paste this on 4 more key points. Hopefully I can draw this out far enough. Didn't leave nearly enough room, so that's a learning moment for all of us. Make sure you leave enough room. So another pi/4 becomes 5 pi/4. And then, what would that be? 3 pi/2. Let's make sure we're in the right, different color here. 7 pi/4. And then all the way over to 2 pi. So everything just gets copy-pasted now. Up to 3 halves. Down to 1 again. down to 1/2, sorry, and then back up to 1. So this is my 1/2 sine 2x plus 1 over 0 to 2 pi. That's 2 full cycles. Now remember, when we draw cosecant has asymptotes. But do you remember where the asymptotes were? They were at the second key point, or if you want to think of it in terms of the points that they share. Cosecant and sine, they share the highs and the lows. The peaks and the valleys, they share those. And then at every other key point, there's an asymptote. So those green lines now are my asymptotes. And then cosecant just goes up and makes parabolic looking things, upward and then downward. And then down. So that green curve there, hopefully it's not too hard to see, is my 1/2 cosecant 2x plus 1. See, what I did, and if you want to think of it the same way, that's great. If you have a different way, that's cool too. I like to think of it in terms of sine first. So I drew 1/2 sine 2x plus 1. Figured out what that thing looked like, and then I knew where my asymptotes were, and the fact that cosecant and sine, they share these highs and lows. Then they just make parabolic motion. And then you have to draw in your asymptotes, because without them, we don't know what's really happening in this end behavior as we go up and we go down. So in order to get full points, you have to draw your asymptotes. So go ahead and write your summary and any questions you have, and take a look at the assignment. Good job today. Do some problems, and hopefully this will make a little bit more sense.